Hello everyone. Good evening to all. My name is Abhishek Pandey. I'm a Prime Minister Research Fellow in the discipline of mathematics at IIT Bhubaneswar. Today we are going to talk about Week 5 assignment, and if time permits, I will I will do some assignment problems from the Week 4. Okay. Okay. So let us start now. I hope I am audible and the screen is visible to everyone. Okay. So first let us start with the Fubini's theorem. What does it say is, so first I will recall some basic facts and then we will start solving the problems. Okay. So, so let me start with the basic fact, Fubini's theorem. Okay. I hope I am audible. Hello.
Yes, sir, you are audible.
Okay. And the screen is visible.
Yes, sir.
Okay. Fine. Nice. So Fubini's theorem. So this is first form. So as I said, uh, first I will recall some basic facts and then we will start solving the problems. So let fx comma y be continuous throughout 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 the rectangular region R. So basically it is xa to b and yc to d. Okay. So then what it says is that, so this is double integral fxy, this area element, this is nothing but equal to c to d, a to b. So so earlier as I mentioned, uh, just wait. Okay. So earlier as I mentioned that this dx denotes this integral, okay, and this dy is for this one, okay. This is equals to a to b, c to d, dy dx. Okay. Now again, we will see the stronger form of Fubini's theorem. Okay, so let me write it from the next page. So Fubini's theorem, stronger form. Okay. So let f be continuous on a region R. Okay. So now R can be of two forms. Okay. So first one is if R is something like say x a to b and y is okay, where g1 comma z2 are continuous on a comma b, then this double integral dA is equals to a to b g1x z2x fxy dy dx. Okay. The second thing is if R is b and x is in between something h1 of y and h2 of y, where h1 comma h2 are continuous on c comma d, then we have this r. Okay, so then they have f of x comma y dA is basically equals to h1 of x h2 of y, sorry, fxy dx dy, and this is nothing but c to d. Okay, I hope this is clear. Abad, is it clear?
Yes, sir.
Okay. So now we'll see change of order of integration. Okay. So sometimes whatever the integration is given, double integral, sometimes it is quite difficult and it is almost impossible to quite integrate with respect to the, yeah, integrate how is it given in the original form. Okay, like suppose let me write it down. Okay, so sometimes it is quite possible that say fxy dy dx is given. So sometimes what happens is this fxy, so if you want to, first you will calculate this thing, isn't it? Okay, so sometimes it is quite difficult to integrate this thing with respect to y, considering x as a constant. Okay, but once you change the order of the integration, now this is with respect to x. Okay, this becomes quite familiar. Okay, I mean, you can do this integration uh, quite easily rather than this integral. Okay, I hope the motivation of change of order of integration is clear. Yeah, yeah. Raised a hand. Yeah, yeah. Tell me. Hello. Yeah, any doubt? Hello. Any doubt? Abad, Parimala.
No, sir.
Yeah, Dr. Parimala.
Sir, it is strongly touched, sir. No, sir, no. Sir.
Okay, okay, okay. Okay, so let us see one example. Okay, so order of integration. Okay, so let us see this example. Okay, so in this example, this is the, I mean, this is the range of y. Okay, y equals from, y is from x squared to 9, x is from 0 to 3. Okay, so if we draw this one, okay, so, so this is y equals to x square. Okay, let's say, oh, let's say this is y equals to 9, y equals to x square. Okay, this is 3 comma 9. This is x equals to 0. This is x equals to 3. So if you see in this integral, you have to integrate ey to the power 3 dy. So you have to first integrate this thing with respect to y, which is quite difficult. Okay, rather than, what we will do is we will change the order of integration. so that this dy dx will become dx dy, and then we will integrate x cube with respect to x, which is quite easy. Okay, so this is the advantage of changing the order of integration. Okay, so here's the thing. So so for that, what we will do, we will choose this. So since we have to change dy to dx, so what we will do, we'll take small. So this is basically your area element. Okay, what we'll do, we will small rectangle kind of thing of width kind of dx, grid kind of thing. Okay, so this is basically your dy, and okay, fine. So now now in this one, what is your, okay, so what is your x on this one? So on this grid, what we will do, we will rotate like this. Okay, so this will go here and like this. Okay, so on this one, okay, so on this one, what is your x? X is 0, and here x is root over y. Okay, so this integral will be x cube ey to the power q dx dy. So this is dx will be with respect to ds, uh, 0 and under root y, and y will run from so here y will be 0 and here y will be 9, so y equals to 0 to 9. Now this is quite easy to solve. So the answer will be 1 by 12 e to the power 729 minus 1. This I have already solved. So now integrating this thing is quite easy, isn't it? So this thing, integrating this thing is quite easy now. So now is it clear how to change the order of the integration?
Yes, sir.
Right. Now we'll see the change of variables. Change of variables is also quite important. Change of change of variables. So let us see what happens in the one variable case. So in one variable, integral of the form let us say a to b f of g of x into g dash x dx. Okay, so such kind of integration are quite easy if you change the variable. Like let g of x is equals to t, so you will get gx dx is equals to dt. Okay, so this integration will become some c to d f of t dt. Okay, now this is in the standard form. Okay, so similar thing we want to do in the several variable case. Okay, mainly in double and triple integral. So what so our aim is to do something something similar for double and triple integral. Okay, So, so before going to do such kind of things, we need to see how our region changes once we apply that uh, once we apply some transformation. Okay, so this is some kind of transformation. Okay, the same transformation if we apply in the two and three variable case, how our region change region of integration changes, that also we need to check. Okay, so like suppose so let R be an ellipse. X square of 1 plus y square upon 16 equals to 1. Okay, and the transformation is x is equals to u by 2 and y equals to 2v. Okay, so with this one, let us say u square. Once you are doing this transformation, this will become 1. Okay, this implies u square plus v square equals to 4. So this is now circle. Okay, so region gets changes. Okay, so now earlier it was an ellipse, now this is a circle. Okay, similarly once you apply the transformation, this thing will get changed, region will get changed. Now let us move towards the definition in general. So suppose that we want to integrate f of x comma y over the region R under the transformation x is equals to g u comma v and y equals to h u comma v. The region R becomes, some regions say S, and the integral becomes, so this is nothing but, say this is R dA is nothing but S f of g v comma h u comma v, and this is, and into, this is nothing but determinant of the Jacobian of the transformation. Okay, du dv. So this is your general formula. Okay, now in two variable there is very familiar coordinate changes known as polar coordinate, and in three variable spherical and cylindrical coordinates. So those things we will discuss: polar, spherical, and cylindrical. Okay, so in polar our coordinates are r comma theta. Okay, where x is equals to r cos theta, y equals to r sin theta. Okay, and the area will become area area element dr d theta. Okay, so like here if you see this dA is nothing but determinant of this one. Okay, so here also, like if you have, so once you have x equals to r cos theta, y equals to r sin theta, so del x by del r will be minus, so del x by del r is cos theta, del x by del theta is minus r sin theta, del x by del theta is, sorry, del y, so del y by del r, so this is nothing but sin theta, and del y by del theta is r cos theta. Okay, so this will become basically Jacobian cos theta minus r sin theta r cos theta. Okay, so this is nothing but r cos square theta minus, so minus minus plus r sin square theta. So this is r. So from this we are getting this one. Okay, so this is your polar coordinate change. Now we'll move towards the spherical. Okay, so in spherical we have, in spherical rho theta phi. Okay, where, so x is equals to rho sin phi cos theta, y equals to rho sin phi sin theta, and z is equals to rho cos phi. Okay, so your area element will become, volume element will become rho square sin phi d rho d theta d phi. This is spherical. Now cylindrical. So in cylindrical, your coordinates are r, theta, and z. So cylindrical is basically, so cylindrical coordinate is basically a generalization of polar coordinate in three variables. So basically here x is equals to r cos theta, y is equals to r sin theta, and z is equals to z. Okay, so here volume element dz dx dy r dz dr d theta. Okay, so I hope up to this is clear, everything is clear. Hello, so these are just some coordinate changes which we'll use frequently. Is it clear? Okay, so also let us see some special functions. First one is gamma function. Okay, so this is, so let x is positive, so gamma of x is nothing but integral 0 to infinity t to the power x minus 1 e to the power minus t dt. So I hope this is clear. If I'm writing this definition incorrect something, just let me know. Okay, so some properties we will also see. So gamma of x plus 1 is equals to x gamma x. Okay, and some of the values I will write. Just wait. Okay, so second one is gamma of gamma of 1 by 2 is root over pi. Third one is gamma of 1 by 3 into gamma of 2 by 3 is equals to 2 pi root over 3 by 3. Fourth one is something gamma of gamma of x plus 1 by 2 is equals to root over pi 2 x minus 1 gamma of 2x. Okay. So let us see the beta function, because sometimes the integral will come in these forms only. Okay, so beta of x comma y is basically defined as integral 0 to 1 t x minus 1 1 minus t y minus 1 dt. So where x is positive and y is positive. Okay, so you can see here that if x and y both are greater than 1, okay, this integral is basically a proper integral. Okay, because the integral will converge, all the things are there. But once x is in between 0 and 1 and y is in between 0 to 1, this integral is improper. But you can show that anyhow the integral will converge. Okay, so means the beta function is well defined. Okay, some properties are, so beta of x comma y is equals to beta of y comma x. Second one is beta of x comma y is basically gamma of x into gamma of y upon gamma of x plus y. Okay, I hope up to everything is clear. Now we'll move towards the assignment problem. I hope up to this everything is clear.
Yes, sir.
Okay. So the first problem is we need to find the value of double integral okay. So now if you see that this integration of e to the power y square with respect to y is quite difficult here. Okay, so we will change the order of the integration. Okay, so here your y equals to x to y equals to 1 and x is 0 to x equals to 1. Okay, so here what we'll do, so this is your y equals to x, this is y equals to x, and this is your y equals to 1. So this is 1 comma 1, this is 1, this is 0, this is 0 comma 1. Okay, so we need to change the order of the integration. Okay, so for that what we will do, so here limit of y is given. Now we have to find the limit of x, okay, in terms of y. So what we'll do, we will place a grid. This is dy, Okay, so not now the integration, let us say I. So now I will become, so what is, so what will be the limit of x? X is from 0 to, so x is from 0 to y, and y is from 0 to 1. Okay, this is e to the power y square dy dx, sorry, dx dy. So now this thing is easy, 0 to 1. So this will become y e to the power y square dy. Okay, now I is equals to integral 0 to 1 e to the y square dy. So now let y square equals to t. So this implies y dy equals to dt by 2. Okay, so this is 1 by 2 integral 0 to 1 e to the power t dt. Okay, so this is the thing, but again e to the power t, e to the power t 1 by 2 0 to 1. So e minus 1 by, okay, is it clear? This is your answer. I hope this is clear.
Yes, sir.
Okay, now the question 2 is, so let I is equals to a to e to the power pi by 4, okay, and 2 log base e r by a to pi by 2 f r theta r d theta dr. Okay, so this we need to change the order, change the order of integration, change the order of the integration. Okay, so basically theta is equals to 2 log base e r by a, okay, and 2 theta is equals to pi by 2, and r is from a to a e to the power pi by 4. Okay, so this will become theta is equals to log base e r square by a square, isn't it? Is it clear? This one,
Yes, sir.
this one. Okay, so this will become e to the power theta is equals to r square by a square. Okay, okay, now this thing will become, so now we need to write f r comma theta r dr d theta. Okay, so now here we need to put the uh, Now here we need to put the limit of r with respect to theta, okay, and here we need to put the limit of uh, theta, okay. So now in this case, once you change the order of the integration, uh, so this will become, just wait, okay, wait. Here what we can do is let it be 2 only, 2 r by a. So this will imply r is equals to a e to the power. So r is equals to a, just wait. So r is equals to uh, r is equals to a e to the power theta by 2. Is it correct?
Yes, sir.
Okay. And okay. So once you see, okay, so see now, now once you put uh, now once you put theta is equals to this, if you put theta equals to this here, what you will get? R equals to, hello, so you will get this value only, isn't it? What I'm saying is, to get r equals to a, what should be theta? Yeah, so theta should be, well, that will be -1. So your theta will be, simply you can take theta equals to 0, isn't it? Lowest.
Zero.
Yeah. So theta will be 0. Okay. So you will get r equals to a. Now theta equals to pi by 2. What you will get? R equals to, so theta equals to pi by 2. You will get r equals to a into e to the power pi by 4. So this thing, sorry. So to get r equals to a, your theta should be 0. To get this thing, your theta should be pi by 2. So basically the limit of theta is nothing but theta equals to 0 to pi by 2, okay, and r is a to a e to the power theta by 2. Is it clear? Is it clear to everyone? Any doubt? Okay. So this is the change of the order of integration, okay, for this one. Okay, let us see the question number 3.
No?
Sorry?
Can we think that geometrically?
Just wait. R equals to a to r equals to, yes, please tell me. Hello? Yeah, please. Yeah, Dinesh.
Yes, sir. Can we think this geometrically means can you draw the picture of this?
Yeah. Then in that case, what you need to do is you need to change this in the in the. So this is in a polar coordinate. You need to change this in the Cartesian coordinate. Then you will get some limit of x and y. Then geometrically you can do this thing, whatever we have done here, like this kind of thing. Okay, so what I'm saying is, geometrically what we have to do, this r comma theta you need to change in x comma y. Again you have to go to the Cartesian coordinate. Okay, otherwise you need to draw this picture in a polar coordinate. Okay, drawing pictures in polar coordinate is not so easy. Like you have to run this r a e to the power theta by 2, then against this theta. Better is to you change the polar coordinate in the Cartesian coordinate. Okay, then you will get the limit of y and x. Okay, so this will become d theta dr will become, let us say, dy. Okay, so let us say uh, you have to change r dr d theta, so you need dx dy. Okay, so you need x as a variable of y, integration limit of x as a variable of y. There you can use this grid, whatever we have done, whatever the reason you will get.
Okay, okay, sir.
Okay, so like earlier I have said, changing the order of integration, key point is, okay, so what I said that once you're changing the variable. Okay, so here we are changing the variable x. So we are, by the transformation, so x we are changing by r and theta, and similarly y r and theta. Okay, so the reason of integration will also get changed. Okay, so that you all, so those things you have to keep in mind. Like in this case, if you take the region as ellipse and take the transformation this. Okay, so this ellipse will change into circle. Okay, so in these cases, like elementary uh, in elementary kind of objects like ellipse, circles, rectangle, it is easy to see the geometrically how the region is getting changed. But in this case things are complicated. Okay, so you need to restrict yourself to, like, do this by your hand only. Okay, like,
Okay.
mhm. The question number 3 is, so the question is, which polar coordinate pair does not label the same point. Okay, so the options are 1 comma pi by 4 comma 1 comma 9 pi by 4. Second option is 2 comma minus 4 pi comma 2 comma 6 pi. Okay, third one is 3 comma 13 pi by 6 minus 3 comma minus 5 pi by 6. Fourth one is 4 comma minus pi by 3, 4 comma 7 pi by 3. Let's see the solution. So for that, I think I have written the question wrongly. This is something else. Okay, sorry, this is not week 4 assignment question. Sorry, this is week 5. So question number 3 is basically the value of 0 to 1 x to the power 5 1 minus x to the power 4 dx is, first one is beta 5 comma 6, second one is beta 5 comma 4, third one is beta 7 comma 6, fourth one is beta 6 comma 5. Okay, so I think this is quite easy. So if you see the definition of beta function, and you know that beta of x comma y equals to beta of y comma x, so I think you guys can tell me what will be the answer. Anyone? So this is the definition of beta of xy, and you need to calculate this integral x to the power 5 1 minus x to the power 4.
I think fourth one, beta of 6 comma 5.
Beta of
6 comma 5.
yeah. So the question is the volume of region bounded from above the plane z is equals to 4 minus x minus 2y and bounded from below by equation x square plus y square equals to 1, okay, is equal to, first one is pi by 4, second one is pi by 2, third one is 4 pi, fourth one is 2 pi. Okay, so this we need to calculate. Okay, so see, okay, so here if we take f of x comma y as 4 minus x minus 2y, okay, and what we'll do, we'll change this thing to polar coordinate. So x is equals to r cos theta and y equals to r sin theta. Okay, so this we will get f of x comma y is equals to 4 minus r cos theta minus 2r sin theta. Okay, so this double integral f x comma y, let us say this is the region R, dA is nothing but, now let us say f of x comma y, or we should write r comma theta. So this is f of r comma theta r dr d theta. Okay, now we need to put the limit of r and theta. Okay, so the double integral r f of x comma y dA is nothing but f of r comma theta r dr d theta. So here we need to put the limit now. So x is from r cos theta, and so okay, so x is equals to r cos theta, y equals to r sin theta. Okay, so Now if you see this circle, okay, so what would be the range of r and theta if you see this circle? So in this case it is quite easy that r will run from 0 to 1 and theta will run from 0 to 2 pi. Okay, so here this will become r is from 0 to 2 pi, sorry, 0 to 1, r is from 0 to 1, theta is from 0 to 2 pi. Okay, and your fr comma theta is basically 4 minus r cos theta minus 2r sin theta. 4 minus r cos theta minus 2r sin theta into r dr d theta. So this will become 0 to 2 pi, and this will become, now after integrating, this will become 2 r square minus r square by 2. So
R cube by 3.
yeah, so, sorry,
R cube by 3.
yeah, so r cube by 3
Cos theta.
cos theta minus 2 r cube by 3 sin theta. Okay, and this 0 to 1. Okay, so once you put the limit 0 to 2 pi, you will get 2 minus cos theta by 3 minus 2 sin theta by 3. Okay,
Yes, sir.
d theta. Okay, so now this way, this you will get 2 into 2 theta minus, so this you will get,
Sin theta.
sorry, wait,
So that minus sign is as it is.
sin theta by 3, this is plus 2 by 3 cos theta 0 to 2 pi. Okay, now once you put 2 pi, so this is 4 pi, this sine 2 pi is 0, and so this is
Which
plus
is 1.
2 by
2 by 3.
3 minus this is 0 0 0, this 2 by 3, so you will get 4 pi.
4 pi.
Okay, so this is your answer. Okay, so this is the answer. Let us see the question number 5. So question number 5, we need to calculate the value of integral double integral over d e to the power minus x square plus y square dx dy. Your d is nothing but x comma y, such that x is positive, y is positive. Okay, so this is basically this coordinate, this quadrant. Okay, so the value of this integral, the options are pi, second option is pi by 2, third option is pi by 4, fourth option is fourth option is 2 pi.
Again here we are using polar coordinate.
Yeah, again we have to use polar coordinates. So x is equals to r cos theta and y equals to r sin theta. Okay, so this your x square plus y and dx dy is equals to r dr d theta. Okay, so this will become, so your x is positive and y is also positive, so theta will run from,
0 to pi by 2.
yeah, so and r will run from 0 to,
0 to infinity, right?
yeah, so r is from 0 to infinity and theta is from 0 to pi by 2. Okay, e to the power minus r square r dr d theta. Okay, now this is easy to integrate. Take r square equals to some constant. So this will become pi by 4.
So instead of that, can we use gamma function over here? If I multiplied and divide by 2, then the second integral becomes gamma.
Wait. Which which one? Okay. So you want to say, okay, on this one, 0 to infinity e to the minus r square r dr.
Hmm.
Okay, so for wait. So for gamma function, you need to,
The
so
second definition of
so
gamma
e to the
function
power,
will
yeah, second definition in terms of log.
no, not log. That is gamma n is equals to
Mhm.
2 times integration 0 to infinity x to the power 2n minus 1 e raised to minus x square dx.
I uh, if 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 that integration, that is standard form, is matching with this one, then you can obviously use. Okay.
Okay, sir.
Otherwise, I mean, this is easy. Let's see the question number 6. So if m is greater than minus 1, then the value of the integral to infinity x to the power m e to the power minus n square x square dx is, so options are, so the options is, first one is wait, we don't need to see the options, just directly solved it. So here what we will do, let us take n square x square equals to t. Yeah. Okay. So this implies dx is 1 by 2 n square x dt. Okay. So this integral 0 to infinity x to the power m is now what? So x is basically t to the t upon t to the power 1 by 2 upon n, isn't it?
So instead of this, if I simply put nx is equals to t, then
Then
also we can find this, I think. So can you write one formula for me here?
which formula?
Gamma n is equals to
Okay, wait. So gamma n is equals to
2 times integration 0 to infinity
hmm,
x raised to 2n minus 1
hmm,
into e to the power minus x square dx. So here if I put nx is equals to t,
hmm.
then I can able to convert above integral in this form.
So you want to put, okay, let us see. So let us say nx is equals to t. So your dx will be dt by n. Okay. So this will be 2 by n integral 0 to infinity. So now x to the power 2n. Okay. So x to the
So in
power
the above
m. So
integral,
t to the power m.
there will be no 2.
Sorry. So 1 by n. So this you will get t to the power m upon n to the power m, and e to the power minus x square.
Minus t square, no? We are putting nx is equals to t.
8 raised
e to the power minus t
to 8.
square.
So mx is equals to t. So t to the power m e to the power minus t square dx is dt.
Dx will be dt by n.
Yeah, so n I have taken
We have
outside.
taken n outside.
Now this one,
So this one is, if I compare, then I'm getting
uh,
m is equals to
so
2n
so so
minus
so
1.
suppose if m is so let us say m is equals to 2n minus 1. Okay, so n is equals to m plus 1 by 2. Okay, okay,
So gamma
so
n plus
2
1 by 2 upon
multiplied by 2.
2.
So this will be 2 into 2 into na, sorry, 1 by 2.
1 by 2.
Yeah, so 1 by 2 n to the power m plus 1.
n plus 1.
Okay,
So
and
gamma
gamma
1
of
plus
m plus 1 by 2. Yeah, so this is the answer only. Okay, anyhow, going by the conventional way also, like only this will come. Then again,
okay.
there you have to t to the power, then there it will come t to the power m plus 1 by 2 into e to the power minus t dt, isn't it? Yeah,
Yes, sir.
and this thing will come outside. Okay, fine. Question 7 is so the value of the integral 0 to half x square 1 minus 2x to the power 3 by 2 dx equal to, first option is 2 by 315, second option is 1 by 63, third option is 5 by 315, fourth option is 2 by 63. Okay, so this is question number 7. So what we can do here is that, okay, so if we put, okay, yeah, so 2x is
2x is
equals to
equals
t.
to t.
Okay, so dx is equal, now it will come to the gamma form, 80 by 2.
The beta form.
So
Beta.
oh, sorry, yeah, beta form, 0 to 1 x to the, so this will be t square 1 minus t to the power 3 by 2 dt and 1 by 8. Okay, so this is nothing but 1 by 8 into 0 to 1 t to the power 3 minus 1 1 minus t to the power 5 by 2 minus 1 dt. So this is nothing but 1 by 8 beta of 3 comma 5 by 2. Now how to calculate this one? I have written some formula, I guess.
Convert this in terms of gamma function.
Yeah, gamma we can write. So this one, okay. Or and also one more thing I have written. Just wait. I will write. I forgot to write that thing. It is in terms of, okay, okay, not, no problem. So yeah, so this will be gamma x gamma y. Okay, so this is nothing but 1 by 8 into gamma of 3 gamma of 5 by 2, and this is nothing but gamma of
3 plus 5 by 2.
11 by 2, I guess. Is it correct?
Yes, sir.
Okay, now again this we need to calculate. What will be this one?
1 by 8
Hmm.
into 2 factorial.
And gamma 5 pi by 2, this is pi
3
into,
by 2. 3 by 2 into 1 by 2 into gamma half.
yeah, 3 by 2 into 1 by 2 into gamma of half.
Gamma half.
Gamma half is what?
root pi.
root pi. This is again 9 by
This
2,
is 9 by 2,
7
7
by
by 2,
2, 5 by 2,
5 by 2,
3
3
by
by
2,
2,
1 by 2, gamma.
gamma. Gamma can
So
cancel,
this
3 will
this
also
thing will
cancel,
get cancelled, okay, and 8
so
to
8
8
also get
cancel.
cancelled with 3 2.
Sorry?
We can cancel this 8 by this 3 2s.
Yeah, that's what I'm saying. So this will come 2 by 35, so that's 63, oh, 315. Okay, 2 by 315.
Okay.
Yeah, this is correct. Okay, fine. So let us see. This is question number 7. Question number 8. 8 is again in terms of gamma only. So the value of integral 0 to infinity x to the power minus 3 by 4 upon 1 plus x dx. Okay, the value of integral is equal to, so the options are, okay, so this thing will solve only. Okay, so this we can write it as x to the power 1 by 4 minus 1 upon 1 plus x to the power 1 by 4 plus 1 minus 1 by 4, isn't it?
Yes, sir.
Okay, so now this you can write it as,
I think this is duplication formula.
which formula?
No, don't remember right now.
Gamma x into gamma y.
Gamma x.
Okay, wait, I will, sorry, the stone. So what will be the value of gamma 1 by 4? 0 to infinity x to the power, okay,
1 by
so
4 minus 1.
t to the power 1 by 4 minus 1 e to the power minus t. Okay, this is t to the power 1 by 4 minus 1 into e to the power minus t dt. Okay,
Yes, sir.
okay, better to write x because we are working with x to the power x, and gamma of 3 by 4 is what?
dt will be dx.
Oh yes, thank you. Integral 0 to infinity x to the power 3 by 4 minus 1 e to the power minus x dx, isn't it?
Yes.
Now what we can do, any formula do you know in terms of gamma? Just wait, x to the power, so 1 by 4 plus 1 by, sorry, 3 by 1 by 2, this is 4, so 3 by 4. One thing we know that, okay, so one thing we know that, this we know, gamma of x, this is standard formula, x plus 1 by 2 is basically equals to root over pi 2 to the power x minus 1 into gamma of 2x, isn't it? This is the standard formula I have written. So here if we put 2x is equals to, so this is 1 by 4, so x equals to 1 by 4, so this you will get gamma of sorry. Here you need to observe something. Gamma of 1 by 4, 1 by 4 plus 1 by 2 is nothing but 3 by 4. Okay, this you will get pi 2 to the power 2x, 1 by 2 minus 1, so minus 1 by 2, so this will go upward 2 to the power, so root over 2. Just let me know if I am doing the calculations correctly. Under root 2 pi gamma of 2 into x, so this is 1 by 2. Okay, is
And
it
then
somehow
how
beta?
this with the above one?
This is 0 to 1, but yeah, you're telling something. Hello,
So original question is something different. So how we can connect this with that question?
which question?
So you have written gamma 1 by 4, gamma 3 by 4 is equals to this. So how we can connect this with the original question?
No, no, what I'm trying to do is I'm writing this integral. So here this 3 by 4 we can write 1 by 4 minus 1, isn't it?
Yes.
Okay, and once you do the factor, this you can write is 1 to 1, you can write 1 by 4 plus 3 by 4. Okay, so I'm just trying to connect it with gamma 1 by 4 and gamma 3 by 4, if at all is it is possible. For that I'm only looking in that one, some multiplication, some addition. So x to the power minus 3 by 4, so this will be 1 plus x, and this will be 1 plus 4 plus mm, this will be, okay, later on we'll see this problem. Now we'll see the question number 9. The value of gamma 11 by 2 is, so gamma 11 by 2, this can be written as gamma 11 by 2 is nothing but 9 by 2 gamma 9 by 2. This again can be written as 9 by 2 into 7 by 2 gamma 7 by 2. So we are using the formula gamma of x plus 1 is equals to x gamma of x. Okay, this is 9 by 2 plus 1. So okay, so this is now, so this ultimately this will become 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, gamma of 1 by 2. So this will become 9 into 7 into 5 into 3 into 1 under root pi by 32. Last question. So the last question is the value of the integral, the value of the integral 0 to 1, 0 to root over 1 minus y square, root over x square plus y square 2 into z square dz dx dy. Okay, so we have to find this integral. Options are pi by 30, second is 7 pi by 15, third one is 17 pi by 30, fourth one is 19 pi by 30. Okay, so we need to calculate this double integral. To okay, so here z is from root over x square plus y square to 2. Okay, so what we will do is we will change this to cylindrical coordinate. Cylindrical coordinate. So changing x is equals to rho cos theta, y equals to rho sin theta, and z is equals to z. Okay, so dz dx dy will become r dz dr d theta. Okay, so root over x square plus y square will become r. Okay, so the integral will become this r to 2. Okay, dz z square dz. Now r will run from, so here x is from 0 to 1 minus y square. Okay, so x is from 0 to under root 1 minus y square. Okay, so this means that x square is less than equals to 1 minus y square. So x square plus y square is less than equals to 1. So this implies r is 0 to 1. So r is from 0 to 1 and theta is from, also we have given that y is from 0 to 1. Okay, so if y is from 0 to 1, what will be the value of theta? So if y is from 0 to 1, x is also from 0 to 1. Okay, now this is only in first coordinate. Okay, so theta will run from 0 to pi by 2. Okay, dz dr d theta, and this is nothing but, so z cube by 3, 1 by 3, so this is 8 minus 8, this is r na, so r 8 minus r cube, this is r into r dr 0 to 1, 0 to pi by 2 d theta, and this is nothing but 8r. So r square by 2 is 4r square, so 4 minus 1 by 5, 5 into 1 by 3 into pi by 2. Okay, so this will be 30 and this will be 19 pi. So this is your answer. Okay, so we are done with the assignment 5. Okay, so in the next class we will see assignment 6. week 6 assignment. So today we have completed the week 5 assignment. Okay. So we'll meet in the next live session for week 6 assignment. Till then, thank you everyone. I will close the meeting now.